Good morning.
Morning.
Good morning.
So far, we have just few people, unfortunately, but they are adding. Okay. Oh my God, gosh, now it is the end of April already, April 30th. Let me start one of problems and wait until other people arrive, and after that I will check attendance. Let me remind you about our section. Last time we started section number 3.5. This is about sum and difference formulas. We solved some problems, and I hope that this was the last problem. I think it was problem number 34. Number 34 on page 227. Problem number 34. Is it that problem, the last one, which we solved last time?
Yes.
Yeah.
Okay, thank you. These are formulas of a sum and a difference of sine, cosine, and tangent functions. And I would like to work right now with problems on page 228, but maybe you have some questions in your mind, and you are welcome to ask me. Only please do that in timely manner, because every minute is very important for us. I'm ready to answer your questions. Do you have any particular problem from homework from page 227? Guys, English has two words, yes and no.
No, for me.
No.
No. Okay, if something comes to your mind, you are welcome to ask me to help you. What do we have in problem number 39 and 40? There are two similar problems. One of functions is given, the location of our angle theta is given, and we need to find the exact value of given expressions. These are absolutely, number 39 and number 40, absolutely similar problems to problems which we worked with. The problem number 34 was from that spot. I'm talking about problems from 33 to 38. So 39 and 40 are same type of absolutely problems. The only difference is that if you look at what you are being asked about, you can see one of reference angles in parentheses. This is why I would like to ask you to choose one of parts. Number 39 has A through D problems, and same thing with number 40. I do not mind just which one you will be choosing, but I am not planning to solve all problems from A to D. And please choose your part, or from 39 or from number 40. Which one you like to see right now, and we can start with that problem. I'm waiting.
40.
40, which part?
B.
Did you say B?
Yeah.
Okay. Let's do that. I'm going to copy what I have in the 40 part B. First, cosine theta equals 1/4. Theta in quadrant 4, which means theta belongs to quadrant number 4. What should we find? We need to find sine parenthesis theta minus pi over 6. This how I wrote that problem. Cosine equals to 1/4. Theta belongs to the 4th quadrant, and there is the expression which we need to find the value for. Let's start. First thing, what we need to do, let's expand that expression. Which one? Sine parenthesis theta minus pi over 6. Is it the sine of difference of two angles? I'm waiting for your reply, guys.
Yeah.
Again, is it a sine of a difference of two angles? So is it so difficult to answer looking at that expression? Difference, is it a result of subtraction?
Yes.
Yeah.
Theta minus pi over 6, is it a difference of two angles?
Yes.
Yes.
Sine of that, is it a sine of difference of two angles?
Yes.
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 So it should not be confusing, which means we need to apply formula number 5. Only understand, please, that theta works here as your alpha and pi over 6 is your beta from the formula. So which means it will be equal to sine of the first angle, which is theta, times cosine of pi over 6 minus, because for sine we have matching signs. If we have minus in parentheses in the expanded form, we also will have a difference. Cosine theta times sine of pi over 6. I expanded this expression using formula number 5 from this section. And now I will underline pieces which are given or which I know the values for. I'm starting with the first product. I'm underlining cosine of pi over 6. Why? Because it is a reference angle. We definitely should know value of that. Cosine theta is given in the problem. It is equal to 1/4. Sine of pi over 6 is another value which we need to know because it is a sine of one of reference angles. So practically, I did not underline only one piece and I'm placing question mark. I'm just doing this. It is not a requirement to underline or place a question mark. I'm just trying to do that to make it more visual. So practically, I have only one unknown. If I can manage to find the value of sine theta, I can finish the problem. And let's see what we have for that. Do we know the location of the angle? Is it given in the problem?
Yes.
Ladies and gentlemen, don't forget about class participation. Great. I know your voices because I worked with you face to face. So if you like to get quite nice looking class participation, great. Please participate our discussions. So do we know the value of cosine of theta? Yes.
Yes.
We know the location and we know cosine theta. Can we easily find sine theta? Yes.
Yeah.
Yes.
Because we can use Pythagorean trigonometric identity. Sine squared theta plus cosine squared theta equals to 1. And I'm going to plug, instead of cosine theta, 1/4 and square it. So we are getting sine squared theta plus 1/4 squared will be 1/16 equals 1. So which means that sine squared theta equals 1 minus 1/16. If we subtract 1/16 from 1, treating 1 like 16/16, are we getting sine squared theta equals to 15/16?
Yes.
Yes.
Take square root from both sides. And don't forget, theta is from fourth quadrant. By the way, sine as a function is positive or negative in the fourth quadrant?
Right.
Negative.
Yeah.
I could not hear. Can you do that louder, please?
Negative.
It's
Negative, definitely, because it is affiliated with y coordinate or equals to y coordinate in the unit trigonometric circle. In the fourth quadrant, y coordinate is negative because fourth quadrant is below x-axis. So which means sine theta equals negative square root of 15. Square root of 16 is 4. And this is your value for sine theta. After I found that, I'm coming back to that line where I underlined. I put an equal sign and I will continue, as you can see. And now I am proceeding. First was sine theta. The value is negative square root of 15/4. What about cosine pi/6? What it is equal to?
1/2.
Square root of 3/2. Minus, what is the value of cosine theta from our problem? Is it 1/4?
4.
Yes.
yes.
And the other one here is sine of pi/6. What is the value of sine of pi/6?
Square root of 3/2.
No. It is not that kind of angle where cosine and sine share same values. Cosine of 3/2 was cosine of pi/6. What about sine? Do we have anyone who knows that value, which we learned a long time ago in chapter 2?
But that's part. What is
It is
sine?
1/2, guys. So I all the time say, review formulas, review values. Unfortunately, you do not listen to my advice. This is quite sad. So now this is what I had, plugging numbers. And now I am going to use or just algebra and arithmetics to simplify. Square root of 15 times square root of 3 is square root of 45, because 15 times 3 is 45. 4 times 2 is 8. So first piece is negative square root of 45 over 8. 1/4 times 1/2 is 1/8. Both are negative. Okay, I can combine them in one piece. 8 is downstairs. On the top, I have negative square root of 45 minus 1. 45 is not a perfect square, but 45, can I replace 45 by 9 times 5?
Yes.
And why do you think I did that?
I don't know.
Because 9 is a perfect square, and I can simplify that root. So I'm doing that, and I'm going to show that it is 9 times 5 minus 1 over 8. First, they are both negatives. I don't want to have, let's say, on the top so many negatives. I'm going to place that negative sign in front of the fraction, which is very common way to simplify. And square root of 9 is 3. So instead of square root of 45, actually I can easily write 3 square root of 5 plus 1 over 8. And this is your answer. If you do not want to have your answer in this form, let me show at least the second one. Or you can write that this is negative 1/8 parenthesis 3 square root of 5 plus 1. Because we were asked to find exact values, you are stopping right there, because this both, I can even box that answers. They are mathematically legal. And we are done with this problem. Did you have an opportunity to write it down?
Yeah.
Yes.
Yeah.
Okay. So what am I going to do right now? I will tell you to start one of identities, and but I will participate just a little bit later after I'm done with your attendance for today. How does it work for you? Is it okay?
Yeah.
Yeah.
So we have identities on the same page, 228. Identities here are from problem number 47 to problem number 72. I will randomly assign you some of these problems. Let's say problem number 60. Problem number 60 on page 228. Please start working with that identity. You have all required formulas. I really recommend you here to start with left to right. I think it will be a little bit easier. But if you decide to start with right, proving this, going to the left side, I think it will be not dramatic as well because it will be not really a bad method as well. So, but again, in my opinion, if you prove it from left to right, it will be a little bit easier for you. Please start working. I'm copying that problem. I'm putting this on the side. Just 1 second. I am going to have your roster right now. And today, again, is April 30th, and I start reading your names. Bryce,
Here.
Gracia,
Here.
thank you. Alexia,
Here.
Hannah, because I'm looking again at all these names. They are not in alphabetical order. This is why it is easier for me to read. Okay, so Dimitar,
Here.
Benjamin, Jesus,
Here.
I think I saw, can you, Jesus?
Here.
Oh, thank you. Okay, Ariana,
Here.
Axel.
Here.
Axel, don't worry. I received your email. I marked you like being during the class last time. So, and I did not have problems because I checked your name. Okay.
All right, thanks.
Desiree,
Here.
Lila, I'm again looking because sometimes people have not working microphones. Okay. Bhaktima,
Here.
Jessica, Ivona, again, I saw his name here. Devin,
Here.
guys, can you reply please in timely manner? Valeria, okay, that's it. And now let's talk about our identity. How did you start the problem? Did you follow my recommendation? Did you start with the left side?
Yes.
What would you do starting with the left side? Did you copy the bottom, which is a denominator of that fraction, cosine alpha, cosine beta?
Yeah.
But on the top, what do you see on the top? Is it sine of alpha plus beta?
Yes.
Yeah.
Is it match formula number 4?
Yeah.
Yeah.
Let's apply it. So according to this formula, it is sine of the sum of two angles. This y, it will be sine of alpha times cosine of beta plus cosine of alpha times sine of beta. I expanded sine of alpha plus beta according to formula number 4. And what do we have here? This is an algebraic fraction, and I'm going to write something on the side right now, and I will show it to you. Let's say in algebra, we have A plus B over C. I hope everyone knows that we can break this into two pieces, like A over C plus B over C. It is absolutely legal. Two fractions carry the same denominator. Okay, so after that, knowing that it is legal, I am going to break that long fraction into two separate pieces. Sine alpha times cosine beta over cosine alpha times cosine beta plus cosine alpha times sine beta over same thing, cosine alpha, cosine beta. And I will look at precisely at both fractions. They are shorter than the previous one to see maybe anything can be canceled. Yes, we can. We can cancel cosine beta with cosine beta in the first fraction. We can cancel cosine alpha with cosine alpha in the second fraction. We are left with sine alpha over cosine alpha plus sine beta over cosine beta. Sine alpha over cosine alpha is a tangent alpha.
Yeah.
Yes.
Sine beta over cosine beta is a tangent beta.
Yeah.
Is it what we had to prove?
Yeah.
So, and we are done. I'm going to assign you another problem, and I also encourage you to do that work in the same way. And after that, I will again help you. Because can you please start 63, problem number 63? Copy this problem 63, and I will be back. I really apologize. I was so thirsty. Unfortunately, this room is on the 3rd floor. So this is why it took some time. So did you start this problem?
Yeah.
Ladies and gentlemen, did you start problem number 63?
Yeah.
My question is, which side did you start with?
Left.
I think that this time, actually, if I were you, I would start with the right side. Definitely you can start with the left side. But remember about my recommendation. Remember, I all the time was telling you, try to start with that side, which mathematically looks more complicated. I think everyone taking a trigonometry course likes much more sine and cosine than tangent. Is it true?
Yeah.
Yeah.
This why, can you see here on the right side, we have tangent alpha plus tangent beta. Downstairs, we have tangent alpha minus tangent. You have 4 tangents on the right side. In my opinion, definitely that side, right side, looks more complicated than the left side. Was I able to convince you guys about right side being more
Yeah.
complicated than the other side?
Yeah.
Yeah.
I think so.
Is it okay with you if you can restart that problem, starting with the right side?
Yes.
Is it okay with you?
Yeah.
Okay. But now let's see what can be done with that right side. What do you have on the left? Do you have at top and the bottom signs? Yes?
Yeah.
Can we replace tangents by any expression which will have sine in it? Any tangent for any angle. Is it a ratio of sine of that angle to cosine of that angle?
Yes.
Let's replace this each tangent by these fractions coming from trigonometry as a formula for tangent. So what do we have here? We have sine of alpha on the top over cosine of alpha plus, for the second one, which is tangent beta, sine of beta over cosine of beta. Can you see?
Yeah.
Can we do absolutely the same thing in denominator?
Yeah.
Only instead of plus, it will be this minus that one, right?
Yes.
Let's do that. And look what we are having right now. We have quite complicated fraction where we have 4 leveled fraction instead of regularly 2 leveled fractions, right? But can I say that here actually we have the top expression, which we have in numerator, divided by the bottom expression, can we?
Yes.
Can we all the time, if we like, change division, that long fractional line, is it other form of division sign? Yes, because let's say fraction, 1/2. What is the meaning of that? It means 1 divided by 2. Same thing here. Can we convert this into multiplication by the reciprocal, right? This we will do in the next step, not right now. Now, what I'm going to do right now, in this second step, I will keep again 4 levels, bringing each of these top and bottom expressions to the least common denominator. But in the next step, which will be step number 3, I will already come back to the 2-leveled form, converting division into multiplication by the reciprocal. Is it clear?
Yes.
Well,
Yes.
let's do that. If you have two fractions and they have completely different denominators and you like to add them or you like to subtract them, do you need to build LCD, least common denominator? Yes. What do you do if you are adding, let's say, 1/2 and 1/3? Denominator is 2, denominator is 3. They don't have anything in common. Should we just simply multiply 2 by 3 and say that least common denominator will be 6?
Yes.
Same thing here, only instead of 1/2 and 1/3, we have trigonometric fractions. But bottom of the first fraction on the top is cosine alpha. Denominator for the second is cosine beta, which means we need to multiply cosine alpha by cosine beta. And you can see I'm having here main trigonometry, main fractional line, but this is my LCD, cosine alpha times cosine beta. Now I'm going to fill the top. I need to multiply because now I have a different denominator, not just simple cosine alpha like I had before. I'm going to multiply the old top, which was sine alpha, by additional part from new denominator, which is cosine beta. So instead of sine alpha, I'm getting sine alpha times cosine beta. In the same manner, I will work with the second fraction on the top. I have just cosine beta in denominator. Now LCD is cosine alpha, cosine beta. Additional part is cosine alpha. So I need to multiply the top by this additional factor. So it will be cosine alpha times sine beta. This is what I'm getting. Instead of previously discussed numerator in that form for leveled fraction. Absolutely, in the same manner, I can work with the bottom of that for leveled fraction. I also need to build LCD, and we have same pieces cosine alpha in the first fraction downstairs and cosine beta in the second one. So LCD will be same as we had on the top, cosine alpha times cosine beta. This is what I wrote. And now I'm going to take care of the top of that particular fraction which we have downstairs. Again, in the first place, we had cosine alpha in denominator. Additional factor is cosine beta. I am going to multiply the numerator, which is sine alpha, by this cosine of beta. Minus, and the second one, I need to multiply by cosine alpha because its old denominator was just cosine beta. And this is what I'm getting. Did you write it down?
Yeah.
Yes.
And I don't want these 4 levels anymore. I'm going to convert this into multiplication by the reciprocal of the second fraction, which we have downstairs. So it will be sine alpha times cosine beta plus cosine alpha times sine beta over cosine alpha times cosine beta, which is the first one, which I had on the top, multiplied by the reciprocal of the second. So cosine alpha, cosine beta goes upstairs. This product goes upstairs. What we had in numerator goes downstairs in denominator. Take your time, carefully write everything correctly, please. Did you do that?
Yeah.
Yes.
Can we cancel anything? Because we are now practically multiplying one fraction by another fraction. Can you see the expression in the denominator of the first fraction completely matches the new numerator in the second fraction, right?
Yeah.
Yeah.
Their pieces are multiplied by each other. It is cosine alpha times cosine beta. Just cross them completely. Gone. So now on the bottom of the first fraction, I have 1. On the top of the second fraction, I also have 1. But now let's precisely look at these pieces. I'm talking about numerator for the first fraction, denominator for the second. What do we have here? We have here sine alpha times cosine beta plus cosine alpha times sine beta. Is it the expanded form? Where is my list of formulas? Is it an expanded form for formula number 4?
Sine.
Yeah.
Can I replace this by that?
Yeah.
Yes.
Definitely I can. And I need to multiply, when I multiply fractions, numerator by numerator, denominator by denominator. So now I replace the first fraction's numerator by sine of parenthesis alpha plus beta, and I need to multiply it by 1. I'm not going to write by 1 because multiplication by 1 will not change that sign of alpha plus beta. I'm moving downstairs. What do I have downstairs? This, in the first fraction, denominator is 1. But the second one, it is the difference of these products. Does this time remind this expression an expanded form of any of covered by us formulas? It is sine alpha times cosine beta minus cosine alpha times sine beta. Does it remind you anything?
Side A minus.
Is
Oh,
it matching expression in, that's right. Is it matching your expression in number 5 formula?
yeah.
Absolutely good. So, which means sine of alpha minus beta. So we got, finally, sine of alpha plus beta over sine of alpha minus beta. Is it what we had previously in the original problem on the left side?
Yeah.
Can I say that we actually are done with our proof?
Yes.
Yeah.
And can you see I placed that square, which
Yeah.
means, yeah, this is the end of the proof. Excellent. Let me actually move to another spot. And if today I have a little bit more time, maybe I will solve some, because again, here you can see you are just applying formulas, you are using actively algebra and trigonometry together with algebra to prove these identities. I know that quite often these identities can be quite challenging, but unfortunately, I physically do not have time to solve every single one from that spot. I am moving to the next spot, what's also on page number 228. And now this is from 73 to 84. Find the exact value of each expression. Let's say problem number 74. Please copy that problem. Sine. Can you see we again here have arccosine, arc sine of square root of 3 over 2 plus arc cosine of 1.
Yeah.
And the request here is find the exact value of each expression. Before I start working with this problem, I would like to bring something to your attention, and I hope that people who actually originally registered here and after that disappeared, instead of having more students arriving to our virtual lecture, now I have even less. Out of your class now, just 1 second, please. You have today, right now at this moment, only 9 people. This is 50% of the class. I really do not think what they're talking about, but again, I will quickly check attendance right now. So, Bryce.
Here.
Okay. Gracia.
Here.
Alexia.
Here.
Okay. Hannah. Hannah. No, I do not see Hannah. Okay. Dimitar.
Here.
Yes, I see that. Okay. Jesus. 1 second. No Jesus. Okay. People do not understand that there are lists of names on the side. They are just not in alphabetical order. This is why it is easier to check in alphabetical order. This is why I'm reading the names. Ariana.
Here.
Axel.
Here.
Here, I see. Desiree. Desiree. No Desiree. Okay. Baktima. Yes, I see your name. Ivuna. Yes, I see. And Devin.
Here.
Yes, that's it. Okay. Let's go back to this problem. Do you remember that all arccosines are angles?
Yeah.
So, which means we can say that the first one is alpha, let's say. The second one is beta. Alpha and beta. So practically what we have here is a sine of alpha, parenthesis, plus beta, which is the expression matching our formula number 4. Formula number 4. This is why I'm going to use that formula to expand this expression. It will look a little bit more complicated than formula number 4, because in formula number 4, we simply had sine of alpha plus beta. Now, instead of alpha, we have arc sine of square root of 3 over 2. Instead of beta, we have arc cosine of 1. So I'm expanding that formula according to formula which we have in number 4 in our list. So it will be sine of alpha, which is sine of arcsine of square root of 3 over 2, times sine alpha times cosine beta, cosine of arc cosine of 1. This part is only representing sine alpha times cosine beta from formula number 4. But now I need to continue because formula number 4 had sine of alpha times cosine of beta plus cosine of alpha cosine of alpha times sine of beta So this was my first step here. I recognize that formula. Yeah, it came in a little bit strange form, but arcuses are angles. And this why I have all rights to apply that formula for sine of alpha plus beta. Can I continue?
Yeah.
Yeah.
Okay, let's simplify each of these pieces. Look at the first piece. Is it a composition of two inverse to each other functions?
Yeah.
Is it just one person's opinion?
Yes.
Yeah.
Now, square root of 3 over 2, is it in the range of the outside function? In other words, sine of certain angle, can it be equal to square root of 3 over 2?
Yes.
Yes.
Is it actually just for this small piece, sine of arcsine of square root of 3 over 2, the simple answer will be square root of 3 over 2. Do you remember? Sine composed with arcsine of x. If that x is in the range of outside function, that composition will be equal to x.
Yeah.
I am moving to the second piece here. And what do we have here? Cosine of arc cosine of 1. Is it a composition of two inverse to each other functions?
Yes.
Yeah.
That one, which we have inside, is it in the range of outside function? In other words, cosine of certain angle can be equal to 1.
Yeah.
Yeah.
Or this piece will be equal to 1. And this what I have instead of scary first term in this expanded form. I'm moving to the next, and I'm asking myself absolutely same questions. Let's say I'm asking about that first piece. What do we have here? Cosine of arcsine of square root of 3 over 2. Is it a composition of two inverse to each other functions? Cosine composed with arcsine. Cosine and arcsine, are they inverse to each other pieces? No. Which means I cannot do that in that way. But I remember that my angle was alpha, and the second was my angle was beta. I'm going to write this here on the side. So alpha equals arc sine of square root of 3 over 2. By the way, arc sine's range, is it the right half of the circle? Right half of the circle, right?
Yes.
which means first quadrant, fourth quadrant. Can you see this number is positive? Positive square root of 3 over 2.
Yeah.
Does it mean that alpha belongs to the first quadrant?
Yes.
Excellent. Question is, in the first quadrant, which angle has sine equal to square root of 3 over 2?
Pi over 3.
Absolutely accepted. Good lady. Not even good. Awesome. Right. Now let's do the work in the same manner. So I already know alpha is equal to pi over 3. Now I'm talking about beta. Beta is arc cosine of 1. For arc cosine's range, we have the top half of the circle, which means first quadrant and the second quadrant. In first and the second quadrants, which angle has cosine equal to 1?
1.
And it should be actually from the first quadrant because it is positive 1.
0.
One more time.
Cosine 0.
Okay, let's do it. The endpoints of that range, which is first quadrant, second, runs from 0 to pi. 0, pi over 2, pi. What is the cosine of 0?
1.
So is it beta equal to 0 radians?
Yeah.
Yes.
Yeah, definitely. So we have alpha equal to pi over 3, and we have beta equal to 0. This is what I wrote on the side. And now I'm going to plug these values in my problem and proceed after that. I proved here that alpha is pi over 3, beta is 0 radians. So which will be cosine of alpha, which is pi over 3, times sine of beta, and beta is 0. And now I will continue my simplification. Is it square root of 3 times 1, which is just square root of 3 over 2, right? What is the value of cosine of pi over 3? Is it 1/2?
1 half.
Yes.
Yes.
What about sine of 0 radians?
1.
No.
0.
Sine of pi over 2 is 1, but sine of 0 is
0.
0. It is 0. If I multiply 0 by 1/2, is it 0?
Yes.
If I add 0 to square root of 3 over 2, is it square root of 3 over 2?
Yes.
Yeah.
That's it. This is our answer. You can see definitely here we have more steps, more work, but even in this case, this problem is not really extremely hard. Definitely you need to know all these values. I'm willing to solve one more problem from this spot. Are you okay with number 84?
Yeah.
Please copy that, and after that we will have a 5 minutes break. And I choose this problem because I have here tangent. Tangent of arc cosine of 4/5 plus arc sine of 1. This is that problem. Did you copy the problem?
Yeah.
Okay, so I am declaring 5 minutes break. What is time right now? 11:15. So at 11:20, we will continue. Okay?
Okay.
I'm back. Okay. This, what we need to find the value for. Okay. Each time when you start any problem, precisely look at what you have, analyzing the situation. I need to find a tangent of the sum of two angles. Can I say so?
Yeah.
Absolutely correct. Because I can look at this expression as tangent of alpha plus beta. This is what actually I wrote below of each of these expressions. Can you see?
Yeah.
Is it formula number 6, which can help us to solve this problem?
Yeah.
Right?
Yeah.
I'm going to use that formula right now. Again, this is formula number 6 in your list, and it will look as tangent of alpha on the top, which is tangent of arc cosine of 4/5, plus tangent of beta, which will be tangent of arc sine of 1, And what do you have here downstairs? 1 minus tangent of alpha, which is arc cosine of 4/5, multiplied by tangent of beta, which is arc sine of 1. Okay?
Yeah.
Let's see what can be done here. There is arc cosine of 4/5. We do not have any angle in the table of reference angle or quadrantal angle for which cosine will be equal to 4/5. Yeah, cosine definitely can be equal to 4/5 because it is a number between -1 and +1. But this is my alpha. So I'm going to write this on the side. Alpha equals arc cosine of 4/5. And I will try to find tangent for this angle. But first, I like to talk about location of that angle. Is it positive 4/5?
Positive.
For arc cosine, the range is top half of the circle, which means quadrant number 1 and quadrant number 2. Particularly that alpha belongs to which quadrant?
1.
Write it down. Can I apply cosine as a composition to both sides? Yes,
Yeah.
we did it long time ago. Not really, because it was just at the beginning of chapter 3. We were doing this type of work in chapter 3, section 3.2. So it will be cosine alpha equals cosine composed with arc cosine of 4/5. This is why I'm talking about composition.
Could you leap up a little bit?
Is it better?
Yeah. Thank you.
You're welcome. Is it Bhaktima?
Yeah.
Yeah. Yes, Bhaktima, definitely. Sometimes it is difficult to adjust these papers, but if you do not see something, tell me about that right away. So, and let's continue our explanation. What do you see here right now on the right side? Is it a composition inverse to each other functions?
Yes.
4/5, is it in the range of the outside function?
Yes.
Yeah, definitely, because it is the number which is greater than -1 and less than 1. So which means that composition on the right is just equal to 4/5, because we answered yes to both questions. Is it a composition of two inverse to each other functions? Yes. Is 4/5 in the range of outside function? Yes. This is why it is just equal to 4/5. Now, what do you have here? You have a location. It is the first quadrant. You have value of cosine alpha. It is 4/5. But we need to find tangent. For tangent, can we use the formula that it is a sine of this angle over cosine of the same angle? Yes, we can. So which means if I can find sine of that angle, I can easily find tangent. Do you agree with me?
Yeah.
Okay, so let's do that. We are looking for sine. So sine squared alpha plus cosine squared alpha equals to 1. Pythagorean identity. Plug instead of cosine alpha, 4/5, that's square it. If you square it, 4/5 squared will be 16/25 equals to 1. Move 16/25 to the other side. If you subtract 16/25 plus over from 1, 1 minus 16/25 will be equal to what number?
9 over 25.
9, yeah, it will be 9/25, yeah. But we don't need sine squared. Can we take square root from both sides?
Yeah. 3/5.
Yeah. Don't forget about location of alpha. Alpha was from the first quadrant. Which side should I consider here for that square root? Positive, negative, or plus minus?
Positive.
Positive, accepted. And 9 on the top is a perfect square. 25 downstairs in the denominator is a perfect square. So sine alpha has a very good looking answer, 3/5. Now, I know that cosine of alpha is 4/5. I know that sine alpha is equal to 3/5. Can I find the tangent?
Yep.
Yeah, definitely. Write down that tangent is equal to sine alpha over cosine alpha. And plug your numbers. 3/5, 4/5, which is 3/5 times 5/4. Gone, both fives, and tangent is 3/4. Your tangent alpha is 3/4. Okay, so which means in our original problem, in the first step right here where I expanded that, I can replace each of these tangent of our cosine of 4/5 by just 3/4 because this is the value of that tangent. 3/4, 1 minus 3/4, and here, look how I wrote it down. Now, let's look at the second angle, which is beta. Beta is arc sine of 1. This is arc sine function. What is the range of that function? Is it the right half of the circle?
Yes.
A right half of the circle consists of first quadrant and fourth quadrant, right?
Yeah.
That particular beta, is it from the first quadrant or the fourth quadrant?
First.
First. Accepted. So now, apply please here sine to both sides. Sine beta equals sine arc sine of 1. Sine of beta on the other side. Is it a composition of two inverse to each other functions?
Yes.
1, is it in the range of the outside function?
No.
Sine cannot be equal to 1?
Right.
Yes.
Yeah.
One more time. Is it a composition of two inverse to each other functions?
Yeah.
Mhm. Yeah.
1, is it in the range of the outside function?
Mm-hmm.
Yes.
Yeah.
Does it mean that this composition is equal to 1?
Yeah.
Yeah.
So sine beta is equal to 1. So now we can find cosine. Okay. Sine squared beta plus cosine squared beta equals to 1, as we know.
Mhm.
1 is the value of sine beta. If I square it, will be 1. So cosine squared beta equals 1 minus 1, which is 0. I just wanted to make it visual. I could use here shortcut as well, but decided to make it more visual for you, ladies and gentlemen. So does it mean that if cosine squared of beta is 0, I can take square root from both sides and I can get cosine beta is equal to 0? Yes?
Yes.
And look what we have here. We have here sine beta equal to 1, cosine beta is equal to 0, tangent beta is sine of beta over cosine of beta, and this is 1 over 0. Can we divide by 0? No, we cannot, which means this tangent is undefined, because I understand that if arc sine, if we are dealing here with arc sine of 1, it is the main angle for which sine is equal to 1. It is pi over 2. So this, I'm talking right now about another way to solve this problem. So which means it is tangent of pi over 2. Tangent of pi over 2 is undefined. Unfortunately, I need to say that this problem, for sure, according to my opinion, has a typo, because this function of this problem cannot be solved if one of pieces here, it does not exist. This is why I really recommend you to do the following thing. Let's right now fix this mistake typo in the textbook, and in the original problem, and I'm absolutely positive about that, let's switch arc sine of 1 to arc cosine of 1. Arc cosine of 1. And we will fix right now everything. So everywhere where you had arc sine of 1, write down arc cosine of 1. Arc cosine of 1. Everywhere, please. So this why I'm going to do another calculations which are easier. So my beta is arc cosine of 1. Because it is arc cosine, it is the top half of the circle. Because it is positive 1, beta belongs to the first quadrant. And now, in the first quadrant, which angle has arc cosine equal to 1?
1.
It is 0 radians, right?
Yeah.
So, and this is how I easily found that beta. I just did this long way when I showed this to you. I wanted to show, because immediately when I decided to work with this problem, my eyes are trained. I immediately caught something which looked suspicious. This is why I wanted to tell you about that. Definitely book has a typo. So this is why I already know that beta. What about tangent of beta? Tangent of beta is tangent of 0 radians. What is the value of tangent of 0 radians?
0.
0. And I wrote it down. And now I'm going to plug this value into my problem, because it will be 3/4 plus 0. But downstairs, 1 minus 3/4 times 0. Can you see right here? I wrote, and I will continue. So it will be 3/4 plus 0. It is 3/4. 1 minus 3/4 times 0 is another 0. So 3/4 over 1 minus 0, it is 3/4 over 1. And the answer is 3/4. This time problem is solvable. And I'm done with the problem. Questions?
Not right now.
Did I completely confuse everyone? And this why you do not have questions, or you understood entire process?
Just process.
Both.
Definitely, you need to go over this material again, reading your notes. If you like, I will try to post, to upload this video on YouTube. And definitely, this is not very transparent material. With your permission, can I move to another page?
Okay.
Yes.
I would, do we have time? Oh yes, we have just about 10 minutes. I'm on page 229 right now, page 229. And I would like to show how to solve equations. And let's say I will choose problem number 92. These all problems have absolutely same type of method, which I'm going to show. 92. We need to solve each equation on the interval from 0 to 2 pi. Sounds familiar. Let me write down that formula. Or if I said formula, to copy that problem. Theta belongs to the semi-closed interval. This is that equation. But this equation has very specific method. In this method, we will be using the formulas of one of formulas, or number one formula, or number two, or number three, or number four. How? This is the expression A times sine theta plus B times cosine theta. I wrote it on the side. And this is a very common method, very typical international method being used at all countries on our planet. What do we do here? We try to build the value of square root of a squared plus b squared using values of a and b for our problem. According to our problem, our a is square root of 3, our b is 1, and this y, square root of a squared plus b squared, will be equal to square root of 3 squared plus 1 squared, which is equal to square root of 3 plus 1, which is square root of 4, and answer is 2. Can you see?
Yeah.
Again, what did I do? I found the value of square root of a squared plus b squared, where a and b are coefficients of sine and cosine on the left side of that equation. And after that, I will divide both sides of my given equation by this number 2. This is an equation, and I definitely can divide both sides by any number except 0. And I am dividing both sides by this number. I will even box that number. I divided both sides by 2. And now I'm going to simplify. It will be square root of 3 over 2 times sine theta plus 1/2 of cosine of theta equals to 1/2. And now it will depend on what of formulas you can use here. Why I'm saying that? First of all, in your expanded form of the formula, you need to have plus connecting pieces. These are formulas number 2 and number 4. In formulas number 2 and formula number 4, you have in expanded form, you have pluses. Can you see?
Yeah.
Now it will depend of, you can use our second formula or the fourth formula to solve this problem. Honestly, I recommend you, again, both ways are legal, but my recommendation is use formula number 4. It will be a little bit easier for you. Formula number 4 is the formula for the sine of the sum of two angles. And what do you see in this formula, in the expanded form? It is sine multiplied by cosine in both here products. This why, looking at this piece, you need to look at the square root of 3 over 2, if you are using formula number 4, like a cosine of this certain angle, because you already have here sine theta. By the way, square root of 3 over 2 equals to the cosine of what kind of angle?
Pi over 6.
All right, it is sine equal to 1/2, cosine is equal to pi over 6. Absolutely correct. Thank you very much. And actually, I wrote it down. Cosine of pi over 6. I am moving further, plus now for me, because I decided to use formula for sine, which has sine times cosine in both products, I need to treat 1/2 like a sine of certain angle, because cosine theta I already have. So which angle has sine equal to 1/2? Is it same pi over 6?
Yeah.
And look what I'm getting right now. I'm getting cosine of pi over 6 times sine theta plus sine of pi over 6 times cosine theta. And this now is completely matching that formula number 4, because the nature of this method is built in that way that if we assume that one of these numbers represent cosine of certain angle, according to this method, the other number for sure will be sine of the same angle. This why what I have here is sine theta times cosine of pi over 6 plus cosine theta times sine of pi over 6, which I can easily convert into sine of theta plus pi over 6 according to formula number 4. And this what I am getting right now. Sine of theta plus pi over 6 equal to 1/2. And I'm going right now to work with this problem. I am sketching small circle. In my case, it is not too small because I like to have it in decent size that you could see. This is my circle. Sine is, and I'm assuming that this is a unit trigonometric circle. R is equal to 1. It will be easier. I am going to find y equal to 1/2. It is right here at the midpoint above x-axis. And I'm getting 2 points on this circle. On this circle, I have 2 points, which means I'm getting one angle and the second angle. As we did previously, solving equations. So far, so good?
Yeah.
And now I will finish it. So that because my angle is not simple, just theta angle, it is theta plus pi over 6, I will be using the general formula. For these two families, I will have part A, theta plus pi over 6 equals that small angle in the first quadrant has sine equal to 1/2. Is it pi over 6? Guys,
Yes.
but let me write plus 2 pi k, because again, my angle was quite complicated. It is not just simple theta. And I'm writing k belongs to z. We did it so many times. And so for theta, if you move pi over 6 from left to right, you are getting theta equals negative pi over 6 plus pi over 6 plus 2 pi k. You can cancel negative pi over 6 and positive pi over 6 for sure. And you are getting theta equals 2 pi k. So second part B, theta plus pi over 6 equals that angle in the second quadrant. In the second quadrant, this angle is pi minus pi over 6, also plus 2 pi k, because I'm using angle in the second quadrant, and this will be pi minus that small angle, and the small angle size is pi over 6. So which means theta equals, I'm moving pi over 6 to the right, minus pi over 6 plus pi minus pi, another pi over 6 plus 2 pi k, which means theta equals pi. And if you have 2 negative pi over 6, is it negative 2 times pi over 6, guys?
Yes.
If you have 2 pi over 6, is it just pi over 3?
Yes.
So minus pi over 3 plus 2 pi k. So now theta equals 1 pi minus pi over 3 will be 2 pi over 3. And this is the second family of answers. Now I'm going to play with k value to find that answers which belong to first revolution. Only because we are limited by first revolution by request to find angles between 0 and 2 pi in this problem. And I'm writing k equal to 0. I am plugging this into first family from part A. 2 pi times 0, 0 radians. I'm plugging the same thing into second family. In the second family, I have 2 pi over 3 plus 2 pi times 0. It is gone. It is 2 pi over 3. Both are answers because they are both from the first quadrant. So now, second part, k equals to 1. Theta 3 equals 2 pi times 1, which is 2 pi. It does not belong to that interval, because if you look at this interval, you can see 2 pi and right here is open. So which means I'm writing, no, it is not from that interval. Look what I wrote. So which means it is not a solution. And finally, theta 4 equals 2 pi over 3 plus 2 pi times 1, which is 2 pi k. I am not satisfied with 2 pi, but it will be 2 pi plus another piece, which is 2 pi over 3, which means it is actually 360 degrees plus here 120 degrees. It is 480 degrees. It is not in our revolution. It is not our answer as well. So practically, I'm stopping right here. I'm not going to use k equal to 2 or k equal to 3. I'm ready to write a solution set. Solution set is 0 radians, comma, 2 pi over 3 radians. And I am absolutely done with this problem. I completely solved this equation. I am done with this problem, and actually we already ended our class, but again, if you have any question, you can ask me right now. If you do not have anything, I will let you go. What should I do?
You go. Don't worry.
Okay. In this case, everyone have a nice, beautiful day. Please, again, review formulas and values. Do your homework. Watch what you have on my math lab. And I will see you the next time. Have everyone stay safe, stay well, and have a nice, beautiful day. Okay?
You
Thank
too.
you.
Bye.
Bye.
Bye, guys. Bye.